Hey everybody, this is my last video from section 3.4. It's going to be on your quiz 3, a similar problem anyway. I'm going to recap what linear and angular speed are with you. Linear speed, essentially kind of think about this diagram here. If you have this point P that's moving along a circle, okay? Linear speed is tracking how fast position of that point is changing of the point, all right? Angular speed is actually tracking how fast this angle theta is changing as the point P moves. So we're essentially tracking the movement of P. It's so bothersome. Yeah. Okay, so we are tracking the movement of P. For linear speed, we're tracking the movement of theta for angular speed. Okay. All right, so essentially, we're gonna introduce a few more things here. S is actually gonna be distance now. You're probably used to using D for it, but as you progress in your math and science classes, you will start to use S more often. V is speed, and that's probably a lot to do with it being related to velocity, even though it is not velocity. Speed is just a rate without a direction attached. Velocity would be speed with a direction attached. And then T is going to be the time. Okay, so speed equals distance over time. You are already familiar with this. Kind of think of your speedometer in your car. If you're going 65 miles per hour, that's giving you a rate. Okay, so that's the first thing. And then angular speed looks similar in terms of its format, but now omega, this is omega, will represent angular speed. Theta represents your angle. And your T is going to be time. I already see something I want to add up here. Sorry to skip around a little bit, but I want to make sure that you guys emphasize that V is linear speed and omega is angular speed. Okay. All right, so the equation we're going to be using, omega equals theta over T, where theta is in radians. So be very careful about that. If you are given degrees or you're given rotations or revolutions, something like that, you're going to need to convert to radians. Okay, that's our first bit. I'm going to go ahead and clear this out. Now the formulas you're going to be needing for this section, you saw two of them. Just in case you are curious about the notes, let me fill this part in for you. Theta must be measured in radians with omega expressed in radians per unit of time. Okay, so omega would be in radians per second, for example, or radians per minute, for example, okay? If you start with omega as revs per second or degrees per second, you will need to change revs and degrees. as we just discussed. Change to radians. Okay. All right, and so the formula that we have for angular speed, omega equals theta over t. All right, let me go ahead and clear out the bottom here. For linear speed, you're going to have 3 different equations that you could use. One of them is the one that was initially given. You have distance over time. Okay, so for V, some examples, you could have miles per hour or kilometers per second. Okay. All right, so then remember what S is equal to. S is a distance, right? Around the circle. Okay, so some distance that's traveled around the circle. So what else does that remind you of? Arc length. Okay, S is equal to R theta. So what we're going to do, we're going to replace S with R theta. And then time is still in the bottom. Okay. Now though, let's think about another formula we have. Okay, we have a formula for theta over time right here. So we're going to replace theta over time with omega. Okay, so those are the 3 formulas that you can use for linear speed. Okay. So one more thing I want to emphasize before we move on. In terms of units for angular speed, a good way to think about it, you have some angular change per time. It's going to be angular units over time units, as we discussed previously, and units for velocity v, sorry, speed v, linear speed, will be distance units over time units. That'll help you identify the difference, like when you are using angular speed versus linear speed. What unit should I have? All right, let me save that, and then I'm going to clear this out. Okay, let's go ahead and move into your example. We're going to start with part A. We have a point P on a circle with radius 15 inches, and a ray OP is rotating with angular speed pi over 12 radians per second. Okay. First thing we want to do is find the angle generated by P in 10 seconds. So let's go ahead and draw out a diagram to the best of our abilities at this point. Hopefully, oh, let's see if I can just draw a circle. Yay. Don't know why I never noticed that. Okay. We're gonna go ahead and put a little point in here. And we have our array OP. It doesn't matter where it's starting. It doesn't need to be measured from standard position. Okay, point P is moving. We'll say it's this way. Why not? Okay. With an angular speed. So omega equals pi over 12 radians per second. And then we have a radius of 15 inches. Okay. Okay, so we want to find the angle generated by P in 10 seconds. So we're looking for theta. Hopefully you're seeing how this helps you line things up. We have omega, we have R, and we have theta. Okay, so then we go back to our formulas and we see which one would be best to use. So essentially when I'm doing this, I'm thinking, okay, I have omega. I'll just do it in black, it'll be faster. Theta over time. So if we're looking for theta, and we already have the time here too, then we can manipulate this formula here, and omega t equals theta. So theta is equal to omega times t. Seconds cancel. You can simplify the 10 over 12 to 5 over 6. So theta is 5 pi over 6 radians. Okay. If it doesn't ask you to leave it exact, if you wanted to decimal approximate that, you can. So what that comes out to, you have 5 pi over 6. So that's about 2.6 radians. Okay. All right, it's going to be easier to leave it exact throughout this problem, just so that you don't have to worry about rounding. Like if you round here, you have to keep your exact answer, like whatever your calculator gives you throughout the calculation. It's kind of a pain in the butt. So here we go. Let me go ahead and clear this out. I didn't want to clear the circle, dang it. Let me undo that. Aha. And then go for the eraser here. Okay, let's take this away for now, just because it's not quite in the second problem prompt yet. Okay, now we want to find the distance traveled by P along the circle in 10 seconds. So we do still see that the time is going to be the same. Okay, and we're looking for distance, which is S. So we go back to our formulas and we figure, okay, well, how can we get S from the information we have? Okay, well, for one, we have the time, Okay, that's the same as in part A, which means theta is still going to be the same. Okay, so we have theta. I'm going to leave off the radian part now. Remember, it's unitless, so you don't actually have to write it in. We have r and we have theta. Remember, S is equal to r theta. So go ahead and plug in. Okay. And then we wind up getting 25 pi over 2. And that would actually be in inches. Now that does sound a little strange, right? Like, okay, how many times do we say I've gone 25 pi over 2 inches in distance? Not often. So S is approximately 39.3 inches. Okay, typically to avoid the, well, do I use an exact value or do I use the approximation? It'll be given if you need to use exact or if you need to round to something. All right, and then the last problem we are going to go over is part C here. Find the linear speed of P in inches per second. There's actually 2 ways you can do this part. Let me clear out these parts. I don't really want to do that. I guess I can just undo it. Whoa. All right, so I'm gonna get rid of this. And this. So for part C, omega stays constant. R stays constant. Time we can use in one of our methods, but we don't have to. And then we also do not need our theta right now. So let's just think about what our formulas could be at this point. We have that V equals S over T, okay? And we also have V equals R omega. We have V equals R theta over T as well, which technically could be used in this case as well. Give it a shot, see if you need some help with it, or you can just choose one of the 2 methods we're going to go over right here. Okay, so essentially for number 1, if we use the values that we had before, we had S as about 39.3 inches. For this part, it's going to be easier to use exact value. And then your time for that particular distance traveled was 10 seconds. So V would be equal to 25 pi over 2 inches divided by 10 seconds. That is 25/2 inches times 1/10 seconds, which gives you a 25 pi over 20 inches per second, which is 5 pi over 4 inches per second. Again, it's kind of weird to use an exact value for your final answer for a linear speed. So go ahead and find the approximation. It's about 3.9 inches per second. Okay. If we are using the second method, we have R given and we have omega given already. So this would have been the easiest way to use without, using intermediate parts in case you made a mistake. So V equals R times omega. Again, we could write that without needing to write radians in. Okay. Then we get 15 pi over 12 inches per second, which comes out to 5 pi over 4 inches per second, which takes you to the same answer. Okay. All right, if you have questions about any of the stuff I've gone over, please let me know. Remember, you can request a Zoom with me at this point. I will keep you guys posted with some changes for next week. And then, yeah, aside from that, you have 3 tries on your quiz, so please knock it out and let me know if you have questions.